Good afternoon, YouTube. Welcome back to the channel. Was out for a much needed vacation over the Labor Day weekend here in the US. Had a great time visiting some friends out in California. Back though and refreshed and ready to keep studying with you all. It's a little bit later than lunch, but I was catching up this morning with work stuff and doing a bunch of different things just after the long weekend. So doing my study session a little bit later today. The spirit behind this video was originally on quality of service, QoS, which is where we prioritize different types of traffic across our network, or at least across a connection between two devices. And we will still do that, but instead of just following along a pre-built lab, I've decided I'm going to build my own and just kind of work on assembling things like this, get the routing set up, the addressing, IP addressing set up, etc. So we'll kind of go through it and just talk about it as we go. So let's just get started. So first things first, here we are in lovely Packet Tracer. I'm going to set up two routers, and if you do follow along Jeremy IT Labs QoS lab for this content or whatever, you'll see that this routing setup or this network setup is going to look like that, but I'm actually going to do the configuration myself just to get those reps. So we'll have a couple of switches, a couple of routers, and then a PC and a server. And this server will act as our DNS server, so we'll get some reps setting up DNS, which should be kind of cool. And we'll kind of look at the packets as they go by and discuss some things. So I'm going to just do like the auto setup on the routers, router to switch, router to switch, switch to server, and finally switch to PC. All right, so we want to be able to set this up so that PC 0 can ping server 0 and get a DNS record, etc. from it. And we're going to control this traffic across the connection between the two routers using QoS a little bit later in this video. All right, so first things first, we need to set up this subnet between the two routers. We need to set up this subnet over here and this subnet over here so that they can not only ping each other, but share routes, etc. And so let's start with that. So first of all, this connection should be at gigabit 00, which it is. So I'm going to go ahead and set up the IP address for that. And let's set up the interface gigabit 00. No. Okay. enconf interface gigabit 0/0. And we'll give it IP address, and we'll use the is this class B? I think this is class B. 172.168.0.1, and it's going to be a /30. 252. Now 172.16.0, and I'm going to say no shut. All right, so that brings that interface up. Let me Google this real quick. What class address is 172.16. Class B, I was correct. An IP address starting with 172.16 is considered a class B address. I believe class A would be the 10.0s and the class C would be 192.168. So we'll get all three just to get reps. Again, just getting reps doing configuration. All right, so we set up that IP address for the 172.16.0 subnet. Let's do the other side so that those two can start communicating. No. and then en, oh, nope. Okay, en conf t interface gigabit 00, IP address 172.1.6, I'm going to say .2, 172.1.6.0.2, 255.255.255.252. Okay, so this is a /30 subnet, allowing only these two hosts, or these two devices, or addresses. All right, and then no shut. So once that interface comes up, we should see that now there's like the green signal connectivity between these two. And I believe I should already be able to ping the other one. Ping 172.1.6.0.2. Why not? Okay, I gotta can I do a do ping? And yes, I can. Okay. All right, so now let's configure the interfaces on the other side of the router pointing inward so that the devices on the, their internal facing subnets can ping the routers as their, what do they call that? That default endpoint. Oh, I should remember the term, default gateway. All right, so this side, let's see, exit, interface, gigabit, and I assume it did 01. Let's see what this one looks like. Yeah, 01. 0/1, IP address, and let's do the 192, so a class C address, 192.168.0. I don't know, 1, 255.255.255.0, that's a /24. All right, and no shut. All right, so that should be up. Now let's give this thing an IP address. So it's fast Ethernet, again, 192, this subnet is 192.168.0.1 maybe, .10. And it's gonna be a /24, good. And now its default gateway will be this interface here of the router. That'll be where the packets are sent on their way out to a different subnet. So 192.168.0.1. All right, so that configuration is done. Same thing on this side. You may have noticed the host can take a DNS server, which will end up being this server's IP address, which is not yet set. So we're going to do that momentarily. So we want to go into this router's gigabit 01 interface, gigabit 01. And we need to set its IP address. So IP address, let's do 10.0.0.1 255, and we'll make it a /24. But again, this is a type A private address. Then 10.0.0.1 IP address, no shut. All right, so that is up. And let's do the server's IP address. Desktop services config 10.0.0.100. And that's a /24, not a /8. But by default, it would be /8 because it's a 10.0. All right, so that is now done. All right, so then the server's default gateway needs to be the G01 interface of the router here. And again, that was, what was it? 10.0.0.1. Default gateway, 10.0.0.1. All right, and this again was 10.0.0.100. So let's go ahead and set that as the DNS server for host, or for PC0. 100, okay. So now let's confirm a couple things. First of all, PC0 should be able to ping router 0 on its G01 interface, which has the IP address 192.168.0.1. Let's just confirm that. Desktop command prompt ping 192.168.0.1. Okay, it's on the same subnet. So now, can it ping server 0? The answer will be no, but let's just confirm. So we'll say ping 10.0.0.100, destination host unreachable. And why is it? Because there is no routing set up between the two different subnets across this link. So let's do that. So in order to do that, we will share routes using OSPF. So let's do that. Exit. We go to router, OSPF, process ID 1. All right. And then what do we got? We got a bunch of stuff. We're going to say, what do we want to advertise from this router? Which networks? Well, we want to advertise the 192.168.0.0/24 network. Question mark, area 0. And then we want to advertise the link across the middle, 172.16.0.0, and it's a /30.0.0. So a /30 in the subnet mask would be 252. So you just subtract that from 255, the full one, the full range, I guess, and you get 3 for a wildcard mask. Area 0. All right. And then I think that is all I need to do for that. Let's just go with that for now. All right, now let me do it the same thing over here. Router, OSPF, area, no, OSPF process ID 1, area, no, I don't need to do that. Okay. Network, again, the middle area, 172.16.0.0, 0.0.0.3, area 0. Okay, we see that it's already created a neighbor, which is good. And then its internal subnet, which is the 10.0/10.0 network. Network 10.0.0.0/24. That's going to be 0.0.0.255, area 0. And exit. So now let's say do show IP route to see if routes are being exchanged. Okay, we have a route generated by OSPF, which we can see based on this O here, OSPF. All right, and this is router 1. So it is sharing its it's got a route to 192.168.0.0, which is over here via 172.160.1, which is this interface here of router 0. 0.0.172.160.1. Okay, so now I think this should work. So let's see if PC 0 can ping server 0. Why am I pressing that again? Okay, 10.0.0.100. So we would need ARP resolution to take place, and hopefully we will get some replies, which we do. Okay, so that's the quick configuration of our little network. I'm going to try to do that every time now, I think, because I think it's good to get those reps, and I'll try to introduce like little side topics as we go, or even just, you know, just doing things that are valuable to do repeatedly. One thing that I wanted to check out was this. So for a DNS server in Packet Tracer, you can go to services and then you can create records. So for example, let's say showtop.com. we want to create an IPv4 record. So when somebody says, hey, ping showtop.com or access www.showtop.com or whatever, we want it to return, we want this server to return a response with an IP address of 10.0.0.100, which is itself. So I want to be able to say, okay, ping 10.0.0.100 and have I want to say ping showtop.com and have this server respond. All right, and that's for an A record. I want to say, I think quadruple A records are for IPv6. Let me just confirm that. What is an AAAA DNS record? Maps a domain name to an IPv6, and I think CNAME is mapping a name to a name. So I want to say like, okay, ping showtop.com. And now, like, what if I said ping www.showtop.com? We could set up a CNAME record to equate or connect those two on the DNS server so that one would work and the other one would work, etc. All right, so I'm going to add this, and we need to remember to turn the DNS service on. And again, I think we should be able to ping now showtop.com. And we can. All right, so that DNS resolution took place, and we successfully got connectivity and a ping back from the DNS server 0 over here. So the next thing I want to do is just go ahead and ping it again. I want to look at the simulation. Go ahead and kick this off. All right, so when we kick it off, it's going to send a DNS request to figure out like what showtop.com is. But perhaps more importantly, I just want to look at this PDU. When it's leaving router 1 currently, it's got a DSCP value of 0. And I believe, I'm just going to confirm this in a second on Google, but I believe this indicates that it has no priority assigned to it. So there is no quality of service priority being assigned to it. With QoS, or quality of service, we can take different types of traffic, which we're going to do in a second, and apply certain priorities to them so that they get more bandwidth or they get into a priority queue or et cetera. So if you've got traffic that you really need to be highly available, perhaps more so than other traffic, like voice traffic, or I don't know, I guess it just depends on your business needs. But if you've got traffic that needs to be highly available, that doesn't drop, that doesn't get jittery, you can use QoS to manage that. And that's what this content is about, or this topic is about. It's about assigning priority, assigning different queues, and determining, how delicate you need to be with certain types of traffic. All right, so what is what do I want to say here? DSCP. What is a, whoops, that went away. Outbound details. Okay, what's a DSCP value of, what is a DSCP value of 00? DSCP value of 00 designates best effort traffic, meaning that packets this value are treated with no special priority and will be processed in the standard non-prioritized queue, receiving the default level of service from a network device. All right, so I want to now apply some priorities, and ideally we will see that changes on its way out of this router 0. And yeah, so I think one thing to mention, and one thing to mention is that we can turn simulation off. The QoS priorities or values are on a per hop basis, meaning if I say, okay, traffic leaving, HTTP traffic, for example, leaving router 0 on the G00 interface here should be like high priority. Well, it will be high priority across this link, but once it gets over here on the other side of, the neighbor router after the hop, it's up to, again, that link to be configured however the administrator sees fit. That priority does not stay, the priority only stays with the traffic across a single link, okay? So in this video, we're going to focus on router 0 and applying priorities to traffic coming out of the G00 interface. So let's try that. Now, this is the first time I've done this, and we'll see how it goes. So yeah, we can see some neighbor relationships flowing or happening with OSPF. So there is like a map that you need to create, a policy, and these are all to like designate certain types of traffic with specific priorities. So let me just try that first. We have to say class map, and here, let me just grab these real quick. I can't actually do that. All right, so as just an example from the Jeremy IT Labs guide here, I'm looking at it on my laptop. Mark HTTPS traffic. All right, so it says configure the following QoS settings on R1, okay? Provide minimum 10% bandwidth as a priority queue. All right, sorry. Configure the following QoS settings on R1 and apply them outbound on interface G00, which is exactly what we're about to do. Mark HTTPS traffic as AF31, and that's a designation that defines its level of priority. Provide minimum 10% bandwidth as a priority queue. All right, so first of all, let's create this class map for HTTPS traffic. We'll just call it HTTPS_traffic, and I believe that's that. Now, what do we have in here? So we have a description, and then I believe we want to say match. All right, and then what? Match, let's see, access group, no. Any packets, no. COS, destination, input interface, IP specific values, QoS group, or protocol. So we want to match a protocol of HTTPS. MIME URL, match URL string, server host name, no. We just want to match all HTTPS traffic. All right. So I think that part is now done. Let's go and do the same thing. And the next step is mark HTTP traffic. So we'll do class map HTTP_traffic. And again, that was going to be match protocol HTTP. Exit, and then class map ICMP traffic. ICMP. And that's going to be match protocol ICMP. All right, so we've got those. And now if I can say do show running config. Let me get out of here. Show running config. All right, and can we see, okay, so we can see now the class maps we've got. All right, quit And so enconf t. So now I think we need to create policies, and we will assign them to the different class maps. So let's see, policy map, policy name. Let's just do it again. I think let's try it for HTTPS. Policy map, HTTPS, question mark, class. And then we've got HTTPS underscore traffic. Okay, now what? Oh, sweet. This is where we actually define the bandwidth and the priorities. So the first one for HTTPS was provide minimum 10% bandwidth. All right, so priority in a priority queue. Priority percent 10. 10% bandwidth in a priority queue. Okay. That was for HTTPS traffic. Now, let's do HTTP traffic, which is provide minimum 10% bandwidth, but not in a priority queue, in a standard queue. So let me just get out of this again. And we'll do policy map HTTP. What do we have? Class HTTP underscore traffic. All right. And we have now, instead of using the priority keyword, I think we just use the bandwidth keyword, and it's going to be percent. And in this case, we'll do also 10%, but not in a priority queue. All right, as AF32. Mark, next one is ICMP traffic as CS2. Provide minimum 5% bandwidth. Question mark, class. Let's see, this is ICMP underscore traffic. What was it? What did I write? I did not do it. What did I do that for? HTTP ICMP, that's incorrect. So let's do this. No class map HTTP ICMP. Let's get rid of that thing. Exit. No class map ICMP. All right. HTTP underscore ICMP. All right. And then we'll say do show run, and confirm that that's gone, which it is. And then we'll again do class map. And we're going to say ICMP traffic. And we'll do match protocol. If I can type, ICMP. All right, so that's done. Now we want to do the policy again. Policy map ICMP, class ICMP underscore traffic. And this is going to be CS2, provide minimum 5% bandwidth. Bandwidth 5. Okay, now I think that's what we needed to do. Now I think we need to, we've got these policies, right? HTTP, ICMP, and HTTPS. Now I think we need to apply them outbound on G00 from router 1. So let's try that. Interface gigabit Ethernet 00. Configure QoS service policy, priority group. I don't remember which one this is. Bandwidth. I want to say service policy. Assign a priority group to an interface. Let's see what that's about. Priority group 1, no. Service policy. Assign policy map to the output of an interface. Yes. Output. Policy map name. HTTP. HTTPS. Oh, I can only do one. Maybe I should have created them all under the same policy. Okay, so let's try that then. No service policy, HTTP, blah, blah, blah. All right, so now I need to go back out of this. Let's create a new policy map. And we'll just say QoS, and we'll put all 3 different class maps inside of this. And we'll just call it one thing. Class HTTP traffic. Oh, I have to do this again. Okay, so this will be priority %10. Exit. The next one, class HTTPS underscore traffic. And that's going to be bandwidth %10. Exit. And then class ICMP underscore traffic. And it's also going to be bandwidth %5. Exit. All right, so now we've got another policy called QoS. Now let's go back to that interface. Gigabit 0/0. Yes. Question mark. Service policy. Output. QoS. Question mark. Okay, it's applied. Now let's see if that actually does anything. So we will go back over here. And let's do, first of all, we'll test the ICMP and see what it gets applied, what DSCP value is in the PDU outbound after it's coming out of router 1. All right, so let's do that. Showtop.com and enter simulation. Kick that off. All right, so we've got the packet. Now, right now, it should still have a value of 0 because this is DNS traffic, which we did not define. All right, so let's let this stuff go by. I just want to be able to see the traffic that goes by, the type. All right, so blah, blah, blah. DNS. Respond. Okay, so it got the address it needs. Now we have an ICMP packet. So right here, actually let's go one further. This now has what? Anything applied? No, it doesn't. All right, so then the question mark is going outbound from router 0 for ICMP. It does not have anything applied. Is that correct? let's go again. Let's see what it has here. Nothing different for DSCP. Okay. Anything here? Inbound PDU details. So yeah, let's, that doesn't make sense to me. Why doesn't it have any thing applied? I would expect it to have a different, all right, so let's see. Maybe I'm doing something wrong. How to apply QoS on Cisco router packet tracer. Okay, so we need to do class map. Okay, we did that. Define, we use the protocol. Okay. Example with an A. Okay, we created a policy map. We assigned the class and the action, priority %10, bandwidth %5. Set IP DSCP. Okay, we did those. Apply the policy map to an interface. This binds the traffic. So we do interface type. Okay. Verify, show policy map interface. So let's try that. Get rid of this. Exit show policy map interface gigabit 00. All right, so service policy gigabit 00, HTTP traffic match all. ICMP traffic match all, one packet. So it did something. I guess I just didn't see. Let's let it run in real time and see if it increments. Okay, there they go. And here we'll do this again. How many packets went through? So 4 packets went through. So it's working. I guess I just didn't see it. I was expecting okay, so what value in Ethernet header changes when QoS is applied? In layer 2, QoS, the priority code point. Okay. Let's see. Maybe that was the wrong header. So again, simulation. We will ping. Okay, so now DNS is going to get to router 0. And we want to look at the outbound PDU details. And I'm looking for TP ID. Let's see. IHL5, frame check sequence, SFD type, source address, preamble, IHL, no. PCP, I don't even see that. FCS, ID, I only see DSCP, which I thought was the one that we wanted, but I could be wrong. Next, router 1. STP, what the heck? All right, here's another OS or ICMP. Flag 00. Let me check this. Which field to look at in Packet Tracer to confirm QoS is applied? To confirm QoS applied in Packet Tracer, you need to examine the packet details in simulation mode and check the statistics on the router or switch using the CLI commands. Okay. Use the add simple PDU tool to generate traffic between two devices, capture them. Okay. In the details window, click the outbound PDU details tab. Look for one or more of the following IP to confirm QoS is applied. DSCP, differentiated services code point. This is the most common field for modern QoS. A changed value, example from 0 to AF31, indicates that the policy has marked the packet. IP precedence, okay. Well, we can show that as we continue to ping, we can see the number of packets increment. Now we are at 17 that they are matching. So we do know that it's being applied. Sorry, I meant for ICMP. 6 packets have now been captured. So that is working, but I have not been able to see them in the outbound PDU details. When I look at outbound PDU details, I continue to see DSCP 0. So I'm confused about that, but let me just go back to the simulation, and I cannot. Anyway, I'm just going to, for now, assume it's fine, that it is being applied. At a minimum, we got to see the configuration, but that last thing I'll have to figure out and maybe come back with another video or just make an update on my next one, because I'm not really sure why, and we're already kind of a little bit long in this video anyway. So that is it for today. I hope you all enjoyed, and I will see you on the next one. Bye. Good evening, everybody. This is going to be a quick follow-up video to the video I made over lunch today, a little bit earlier on QoS, quality of service. We ran into a confusing point in that video at about the 45-minute mark, and I had to get back to work. So I'm creating this follow-up to talk about that, the issue. All right. The lab we have in front of us, the configuration probably looks a little bit different because while I was away this evening taking kids to soccer practice, making dinner, etc., Packet Tracer crashed and lost the lab that we had configured that was a bit more complex than this. But if you recall correctly, QoS is applied to a single hop. All right, so we were focused here anyway, the connection between router 0 and router 1. And just to describe the issue that we were seeing, first of all, I've gone ahead and set up this router. So I wonder, does Clear work on these routers? I'm not sure. No, it doesn't. Anyway, so let's take a look at show running config. And I want to show you what I've set up so far. So I've given them IP addresses. That's really all I've done. And then I set up the class map the same way we did earlier. So we've got a class map called ICMP map that matches everything under protocol ICMP, okay? And then we put that into a policy map called Gigabit 0, 0 out, which is what this interface is. And it's got the class ICMP map embedded into it. And we're saying drop 10% or like apply 10% into the priority queue. Basically the same configuration we had earlier. And so when the network gets congested, 10% of this traffic will go into a priority queue and take precedence over other traffic. I don't know if you would really apply something like this to ICMP traffic in real life. That'd be a good question if anybody knows the answer to in the comments. But anyway, this is the configuration we had. And my expectation was that when we sent ICMP traffic from router 0 to router 1, we would see in the Ethernet header a non-default value applied to which field. Let me just start the simulation again. I can't even remember the name of the field, but I will find it in a moment. So we're going to do this, and we're going to ping the other router whose IP address is what? 172.160.2. Ping 172.16.0.2. Okay, we're in simulation mode. So let's just drop that here. All right, so I'm going to go. So first of all, it's on router 0, so it's going outbound. And let's look at the PDU details. So DSCP is the field that we expect to update, and it is right now it's default, so it's best effort quality of service. But recall that we applied, what did we apply? The policy to the outbound interface like we see here. So I was wondering, like, why didn't we see this get updated? And I'll go ahead and I'll send this out, and we can see that this is in fact ICMP traffic. So it fits the bill, and we can get a few of these going back and forth, blah, blah, blah. ICMP traffic, okay. So let me just go back to real time. And we jump back into the router here, and we should be able to look at show policy map, question mark, interface, gigabit 00, 0. And we should be able to see that we have in fact gotten 10 packets sent through. 5 I did before this video started, then 5 more just now. Strict priority, 10% of the bandwidth is in the priority queue, etc. But when it was going, like I just said, we didn't see that field change. And I figured out why. There is another command that you need to add to update the header, or get the field in the Ethernet header. So I think we need to do it in the policy. So I'm going to get back into the policy by going conf t, and we'll say policy map. Now the question is, can I edit a policy map? Maybe I can actually. Can I edit a policy map in place? Let's see, let's take the name of this one. All right, so class, and then the word for our class is ICMP map. No, that was wrong. Our policy is this, so let me try to do this again. Exit policy map. I don't want to create a new one. I want to paste this one. And it didn't copy that. That is annoying. Copy. Paste. All right, question mark. And we'll say class No, not class default. ICMP underscore map. All right, so we are now there. Okay, so as you saw in the running config, we already set the priority for this one. The next thing we need to do is set QoS values with the set command. Set IP DSCP, remember that was the field in the Ethernet header, to a particular value. Okay, so let's just pick one. I don't even really know or care. Let's say AF31. AF31. All right, and that's it. That is the command we needed. And I think that will update that header in the IP header, or update the field in the IP header. So let's just confirm do show run config. And what do we have in here now? Okay, so we were able to update the policy map in place. We didn't have to delete it and create a new one. And now, as you can see, we've set 10% of the traffic to the priority queue and set the IP DSCP field to AF31, which is a non-default value. And everything else should be the same. This is still applied outbound on router 0. We just edited it. So let's go ahead and try this again. If we go into simulation and we ping Q, exit, ping 172.16.0.2. All right, so we've got ICMP traffic. Now it's going to be outbound, and yes, we now see that the DSCP field is updated with the new value. Now this value maps to the AF value, and there's a particular way to calculate it. I don't remember off the top of my head. It is something that I will probably need to know for the CCNA, so I'm going to need to study that later. But as far as this lab goes, that's what I was looking to see earlier. Like, why wasn't this changing? It's because we didn't set it as using that set value. The question after that, I looked up already, and I actually already have the answer. But the question was, if you don't, like earlier, we didn't set the DSCP value, and so the question was QoS actually being applied? And the answer is yes, despite the fact that I didn't set that value and couldn't see in the PDU details that it was being applied. It was in fact being applied, at least according to Google's AI. So the question was, if you don't set IP DSCP, does QoS still take effect? Yes, QoS can still take effect even if you don't set an IP DSCP value. They can prioritize this. How QoS works without DSCP marking. So with manual configuration, to apply QoS to packets without a DSCP, you must configure a policy that either matches and acts on other fields. You can define classes that match on VLAN tags, IP addresses, or other criteria, for example, protocol, ICMP protocol, or sets internal marking. So that first option was ours. We set QoS based on protocol type, which is ICMP in this case. And so I believe that it was being applied over that connection, despite the fact that we couldn't see it updating in this IP header field, DSCP. And I think if we go back, I'll go ahead and go to real time and jump in here again. Let's see, show policy map. So then for interface, gigabit 00. And now we've got 15 packets. So we can see that it's incrementing. So I would say, yeah, if, and only 5 of the packets were marked because we had just set it after editing the policy. So a good little exercise. I definitely learned something. And I hope you did too. I'm going to go ahead and post both of these videos tonight, one after the other, so you can get this quick follow-up if you follow along with the other one. But yeah, that is it for now. Hoping to make another, maybe a Python video next in the next couple days. And I am moving on to another topic in my studies, SNMP, SMTP. I can't remember what it's called. I think SNMP, which is the one for managing for managing network equipment. Which protocol allows you to manage network equipment? SNMP, Simple Network Management Protocol. All right, so this is going to be another one of those IP services. SNMP is what we'll be looking at next. All right, have a good night and thank you.